Good afternoon, students. We had completed the last topic of chapter 5 as trigonometric relationship. So, trigonometric relationship is derived from the Pythagoras theorem only. That is, they have combined sine and cos, sec and cot, and then tan and sec. So how they have concluded all these values, we'll see one by one. So cos beta is equal to 1 upon sine beta. So if I complete 1 upon inverse the relation, I will get 90 degree plus sine beta when I write cos beta, that is, sorry, sec beta. Sin beta upon cos beta is equal to tan beta, that is the combination of two. When we derive it from the Pythagoras theorem, then we get sin beta upon cos beta is equal to tan beta. Sin square beta plus cos square beta is equal to 1 plus 1 plus tan square beta is equal to sec square beta, and 1 plus cot square beta is equal to cosec. So these are the relationships or trigonometric relationships using Pythagoras theorem. Next is the sine rule. So the sine rule relates angles and side lengths for a triangle. So they calculate the angles and lengths of those angles. Side A is opposite angle to A, side B is opposite angle to angle B, etc. So how do they write the sine rule? A upon sine A is equal to B upon sine B is equal to C upon sine C. So they write like this the relation of sine rule, that is combination of sine and angle lines together, that is length of the angles. Next is cosine. When I am adding cos with sine, how do I write? The cosine rule explains, as we said, the relationship sine square beta plus cos square beta is equal to 1. So if I combine this relationship with the arbitrary angle, how do I write in three versions? A square is equal to b square plus c square minus 2bc cos A. B square is equal to, if I take b this side and write c square plus a square minus 2ca. I am multiplying 2 with both these. 2ca is cos into cos b. C square is equal to a square plus b square minus 2ab into cos c. So these are the relationships which they hold, and this relationships how they hold further is a is equal to, when they remove square, a is equal to b cos c plus c cos b, that is inverse the proportion with multiplication. bc remains the same, they multiply it with c and b, that is b is multiplied by c and c is multiplied by b. Likewise, they keep b is equal to c multiplied by a cos a and plus a multiplied by cos c. That is, c is equal to further a into cos b plus b into cos a. So these are the inverse relationship which they are taking. That is, they are taking first square with the angle and then they are multiplying angle with the square and they are replicating the squares, that is squares they are removing. This is the formulas for cosine rule. Then the next is compound angles. So let's see the addition and subtraction of two different angles as well as multiplies of the similar angles of two set of a compound trigonometric relationship. So they have common relationships wherein multiplication and addition and subtraction of these two different angles is also done. How do they do that? Suppose if I say that sine a plus minus b is equal to sine a into cos b plus minus cos a into sine b. That is, I can either multiply these factorials as well as I can add and subtract these variables also. So how do I do in different conditions? I do it with the help of, suppose I take cos a plus minus b. So it is cos a into cos b plus minus sine a into sine b. Like priorly it was sine which was multiplied by sine into cos and cos into sine. Here it is cos into cos, sine into sine in this formula. Next is tan a plus minus b, which is tan a plus minus tan b upon 1 minus plus tan A into tan B, that is the inverse ratio. Here they have given it the form of multiplication into division, that is they are doing 4 consideration: multiplication, division, addition, subtraction. So for that, the compound angles which I am getting are, first one is sine 2 beta is equal to 2 sine beta into cos beta. Cos 2 beta is equal to cos square beta minus sine square beta. Cos 2 beta is equal to 2 cos square beta minus 1. Cos 2 beta is equal to 1 minus 2 sine square beta. Sin 3 beta is equal to 3 sine beta minus 4 sine cube beta. Cos 3 beta is equal to 4 cos cube beta minus 3 cos beta. Cos square beta is equal to half into 1 plus cos 2 beta. Sin square beta is equal to half into 1 minus cos 2 beta. So these are the variations of compound angles which are calculated. Next is perimeter relationships. So what are the last topic of this trigonometric topic? Perimeters, how perimeters are calculated. When I say perimeter of an angle, how do I write? I write all the angles and I total it up. Likewise, for trigonometry, how do we apply it? S is equal to half into A plus B plus C. Now A plus B plus C is normal variation, where we say that suppose I have a rectangle, I will have A plus B plus C plus D, that is 4 sides. Likewise, when I take a triangle, I will have A plus B plus C. And for that, when I am combining it with sine and cos, how do I write it? For perimeter, when I am taking sine A upon 2 is equal to root of S minus B into S minus C BC. That is the first one. Second one is when I write sine B upon 2 S minus C, that is I will leave B here. When I say I am multiplying by A, I am removing A as a replicant and I am writing minusing B and C. When I am multiplying it with B, I am multiplying without B, that is C and A. When I am multiplying it with C, I am multiplying it with A and B. So I am taking each and every variable, leaving that variable which I am multiplying. And for that sake, cos A upon 2 is equal to root S into S minus A upon BC. Cos B upon 2 is S into S minus B CA. And cos C upon 2 is S into S minus C. When I am using cos, I am multiplying it with the same value, that is A is A, B is B, C is C. But when I am doing it in sine, I am using the inverse value. So this is the relationship which is used for perimeter of a triangle using trigonometry. When I am doing for sine A, it is 2 upon BC. When I am doing for sine B, it is 2 upon CA. When I am doing for sine C, it is 2 upon AB. So these are the variants which are being taken when I am using perimeter of a triangle for 3 sides, that is using trigonometry. With this we have completed a trigonometry topic. The next topic is interpolation and third topic is curve, which will be concluding in the next lectures, which I will complete. As well, I'll be providing you one assignment and I'll be providing the answer of that assignment also, so that you can refer for your exam point of view. And we have been remaining with one chapter only, that is 7 chapters, some ending part, and 9th chapter with one topic, that is XR, that is virtual devices. And with that we'll complete with our syllabus with 2 lectures more. Thank you.